All right, this is the last section of chapter 1, and we are going to take a look at inverse functions. Now, in some of the previous videos in this chapter, I've kind of mentioned inverse functions or said that there are some special relationships that can happen with inverse functions, and we're going to see all that displayed in this section. So, what makes something a function? Remember, only every input matches with only one output, or each x value matches with only one y value. The other way we saw that was using the vertical line test. And so what we can do here is look at these first examples and kind of determine whether these are functions or not. So a little bit of review here. Looking at all of my x values, they are all unique. I don't have any repeated x values, so this is in fact a function. The second one here, we have 4, 2, 5, 7, negative 3, 2, and 5, negative 1. These 2 points here have the same x value, but it matches with different y values, and that is what makes this not a function. Now, we haven't quite practiced this with an equation yet, but what we can do when we have an equation is try and see, okay, if I plug in values, am I getting 2 out? So if I plug in a x equals 0, I only get 1 out. If I plug in x equals 5, I get 11 out. If I plug in negative 3, I get negative 5 out. I'm only getting one thing out. This is also a linear equation. We know it's a straight line and it'll pass the vertical line test. So this is a function. Now, for this next one, kind of the dead giveaway is this plus or minus sign. If I plug in 0, plus or minus 0 is still just 0, and so I'm only getting one value out. But for everything else I plug in, if I plug in positive 1, well, for x equals 1, I get the square root of 1, which is 1, and I get positive 1, and I get negative 1. If I plug in 2, or let's say 4, the square root of 4 is 2, so I get positive 2 and negative 2. So for each of these x values, I'm getting 2 y values out. So that means this is not a function. Well, how would I find the inverse? How do we find the inverse of an equation? The short answer is that we're going to switch x and y and then solve for y. The domain and range switch as well. This is the function notation that I was using earlier in this chapter, and we will continue to use here. And then we'll come back to this in just a minute. So first off, let's find the inverse of the following. If I have a set of points, the inverse will just be switching the domain and range. So this becomes 2, 1, and 4, negative 3, and 8, 7, and 4, negative 3. And you'll notice I have the same point listed twice here. Having the same point listed twice does not make this not a function. It's just being redundant. I didn't need to list it twice. It's like if I list out all of the people in our class and I list the first person 2 times. It's just being redundant. I didn't need to list them twice. So I've had this point that's the exact same point as this one here, listed twice. That does not make this not a function because the same x value is matching to the same exact y value. Now, if I want to determine if, or find the inverse of this function, I'm going to switch my x and y. And then now I'm going to try and get y by itself. So I'll subtract 1 from both sides. X minus 1 is equal to 2y. Divide by 2. And y is equal to x minus 1 over 2. And then I want to go ahead and use that function notation. So inverse f of x is equal to x minus 1 over 2. If we have a quadratic here, I still switch my x and y. Subtract 3. X minus 3 is equal to y squared. Square root both sides. Plus or minus on this side, and I get y is equal to plus or minus the square root of x minus 3. And again, I can use that function notation. And that would be my inverse. Now we're going to come back to what I just kind of mentioned above here, composition of inverse functions. We saw f of g of x and g of f of x. And if these are equal, then they're inverses of one another. So if f of g of x and g of f of x are equal to each other, switching those orders, then they are inverses. Oops. Okay, so let's take a look at this next example here. And it says are g and f of x inverses? And then they give us these two functions. So what we're going to do is we're going to find g of f of x, and then we're going to find f of g of x. And we have to do both. We can't just do one. And I'm sorry, one more thing. It's not just that these two need to be equal to each other. It's that they also both have to equal exactly x. Okay, they both have to equal x, not just the same thing. They have to equal x. So we're going to find g of f of x. So my outside function is g, 3x minus 6. And I'm going to plug in f of x, 1/3 x plus 2. If I distribute that 3 times 1/3 gives me x. 3 times 2 gives me 6. And then minus 6, that equals exactly x. But I still need to check the other direction. So now my outside function is f 1/3 x plus 2. And I'm plugging in 3x minus 6. Well, 1/3 times 3 gives me just x, and 1/3 times 6 gives me 2, plus 2 equals x. So since they both equal x, f of x and g of x are inverses. This statement is part of your answer. You need to come to that conclusion, but without all of this work, this means absolutely nothing. So I would want to see all of that on a quiz or an exam. All right, we're going to check another set of questions here and see if they are inverses of one another. So again, g of f of x and f of g of x. So here g is my outside function, 2x minus 6, and I'm plugging in 1/2 x minus 3. And distributing that to 2 times 1/2 x gives me just x. 2 times the 3 gives me negative 6 minus 6. Well, negative 6 and minus 6 do not cancel out. That gives me x minus 12. I don't even need to check this one. This tells me everything I need to know. It's not equal to exactly x. Even if this one were equal to the exact same thing, it doesn't matter. They have to be equal to exactly x. So g of x and f of x are not inverses. Okay. All right. So let's look at this next example. And here we have a table of points. So here we're asked to find a few different things. So if this is x and this is f of x, if I wanted to switch my table around and say x and inverse f of x, remember that your domain and range just switch. And these are all just points. I have the point 0, 8. In the inverse, that would be 8, 0. And if I have the point 1, 0 in the original function, then I have the point 0, 1 in the inverse. So I'm going to take a minute here and set this up here. 7, 2, 4, 3, 2, 4, 6, 5, 5, 6, 3, 7, 9, 8, and 1, 9. And now I have a table for both of them. So that can be kind of a helpful tool in answering some of these questions. So for part A, it asks us to find what is f of 1. So x equals 1. My function value there is 0. So f of 1 is equal to 0. Inverse f of 1. Well, now I can, or inverse f of 0, now I can go here and they're telling me my function value is 0. What is the inverse function at 0? It's 1. Okay, and we can see they're using the same point there and they've switched them. For part C, it says solve f of x equals 3. Well, we're asking where does f of x equal 3? And we're looking here at x equals 7. Okay, and then we can ask the question, where does inverse f of x equal 7? Well, inverse f of x at inverse f of x equals 7 at x equals 3. Okay. All right, I'm actually going to add one more example, even though this is where the notes end here. I would like to show you an example of finding the inverse with a rational function. So if I have the equation y is equal to x over x plus 2. Now, not only is it a rational function, but I have two separate x values. So if I want to find the inverse of this kind of an example, I'm going to, again, switch my x and y. So x is equal to y over y plus 2. And what I'm actually going to do now is cross multiply. Well, this x is like x over 1. So y times 1 gives me y. It's equal to x times y plus 2. And right now, I'm going to go ahead and distribute this x. So I have y is equal to xy plus 2x. And I want to get just one y. I'm trying to get y by itself. So I'm going to get this term on the same side as the other y. So I have y minus xy is equal to 2x. And I notice that these two terms have a common factor of y. So I'm going to pull that out, and I'm left with 1 minus x. Well, now I just have one y. That's what I'm solving for here, is this one y. I want to get it by itself. So if I divide both sides by 1 minus x, y is by itself now. And this would be the inverse. And I could always confirm that by plugging them into each other and seeing that they both equal x when you find that. And that brings us to the end of this section and the end of this chapter.